Okay, what's going on? See if I can get my screen working here. Hopefully, if anyone's there, let me know if you can hear me. It's been a little while since I live streamed, and I thought it would be fun to spend some time seeing if we could build a chess engine. So let's take a look at my other monitor. Okay, so yeah, I think the audio is working. Hopefully it's going through the microphone and not my laptop. So first of all, I have no idea what goes into building a chess engine. So really, this should be fairly interesting, hopefully. And I play chess as a hobby, so I've always thought it would be kind of fun to work at building a chess engine and kind of just understanding how they work, but I've never done it before. And it's been a few years since I even really looked into it, so I thought that this might be somewhat of an interesting topic to do over a series of live streams. And maybe we'll just start. My idea was to start just writing the first version of whatever happens here in Python. Clearly, a lot of this is just going to be me sort of like learning what goes into programming a chess engine. And so I expect most of these live streams to be sort of discovering what actually goes into making a chess engine. So there is a chess programming wiki out there called chessprogramming.org. I know this has been around for quite some time, and from what I've read, basically this is probably the best resource in terms of learning how to write a chess engine. And so this is where I'm going to start. And so I'm starting completely from scratch here. I apologize, this might be a pretty boring live stream if you don't like chess, or if you're not interested in watching me try to learn how to build a chess engine. But that's basically what I'm going to be doing in this series. So checking out chessprogramming.org, and from what I've read, really the first place to start is to try to figure out how to do how we're going to do board representation. And so if we click here, there is a getting started page as well. And it says the foundation of a chess engine is the board representation. This is the back end for the chess engine, which controls how it keeps track of the board and the rules. And the very first step is to write a complete bug-free board representation that knows every rule of chess. While sometimes this can be a pain, especially implementing the more complicated rules such as castling and repetition draws, it's the backbone of the chess engine. And it's extremely important to write bug-free code. And once we have a nice solid foundation, then we'll look at search and evaluation. I have a feeling that it's going to take me quite a while just to write a bug-free board representation, so I don't anticipate getting to search or evaluation anytime soon. Shannon's types, after Claude Shannon, the father of information theory. There's a good, he has a good biography. I listened to an audiobook last summer. All right, so let's start with board representation here. And so the idea is that we need to represent clearly all 16 pieces. We could represent the 64 squares on a chessboard with what pieces they contain, or we could represent a piece-centric approach, and I'm pretty sure that this article goes into that here, board representation, piece-centric or square-centric. So a piece-centric approach keeps lists, arrays, or sets of all pieces on the board with the associated information, which square they occupy. Popular piece-centric approach is the set-wise bitboard approach, 164-bit word for each piece type where 1 bits associate their occupancy. I see. So for every piece type, probably for each side, you'd have 164-bit word. So you'd have a bitmap, I guess, of like 0 to 63, one for each square, and it would just be hot for any bit which is occupied and 0 for any bit which is not. And then if you're, I suppose if you sum all of those words, those 64-bit pieces of information, then you have the complete board with all of the pieces. I'm not sure, for instance, what might be the best structure beyond that for doing things like legal moves, but maybe we can start by trying to create a bitboard approach representation for our board. Bitsets or bitmaps represent the board inside a chess program in a piece-centric manner. Bitboards are, in essence, finite sets of up to 64 elements. Squares on a chessboard, 1 bit per square. Other board games may use setwise representations as well, but classical chess has the advantage that one 64-bit word or register covers the whole board. Even more bitboard friendly is checkers. That makes sense because it's every other square, so 32-bit bitboards. To represent the board, we typically need 1 bitboard for each piece type and color, likely encapsulated inside a class or structure, or as an array of bitboards. Okay, let's see. Hey Alvaro, I think I'm going to start with Python, and then I suspect at some point I'll probably move to another language, but yeah, for now I think I'm going to start with Python, unless you guys would prefer to see me start with something else like C#. Yeah, I think Python would probably be the easiest for me to sort of like think about, and once I sort of understand some of the basics of what goes into building a chess engine, I might use another language. All right, so yeah, so to that end, let's just actually start the project. I've got some lag going on here, just a moment. All right, so yeah, I think I'll do it in Python, and the first step is to try to set up this bitboard representation of the board. So it's saying that we need 1 bitboard for each piece type and color, likely encapsulated inside a class or structure or as an array of bitboards as part of a position object. Yeah, I think Python should be easy to follow. The MERN stack, Emu PC Gamer says. I don't know about that, but all right, so let's see. General purpose setwise data structure fitting into 164-bit register. At least for the time being, I'm not going to be thinking super low level in terms of actual bits or registers, but all right, any other ideas coming from this? Bitboard serialization. So this wiki is just there's information that looks like it's spread out sort of all over the place, and so it's not a step-by-step tutorial in creating a chess engine. So a lot of this is going to be me just sort of poking around and referencing various pages. All right, so if we want to create one 64-bit word for each piece type, that's interesting. I kind of wonder why it wouldn't be for each piece. All 32 pieces. And it's also the case that in machine language, type bit by bit. Yep. So it's also the case that I guess it's piece type because, like, theoretically, you could have multiple pieces after promoting. So you could have, like, I suppose, like the maximum number of rooks, for instance, would be 10 because you could have all 8 pawns theoretically promote to rooks. Queens, theoretically, you could have up to 9, I suppose. And then, yeah, so the bitboard for pawns would have at maximum 8 pawns. And yeah, it'll be interesting to see how other things besides like static representation come out of this, like how to generate legal moves, for instance. Okay, and if I get bored at any point and need to take a break, I'll probably just play some chess as well. And if anyone wants to play chess, then let me know what your Lee chess is, or just challenge me on Lee chess and we'll play a game at some point. All right, and I'm not that strong. I'm like 1500, 1600 Lee chess rating. So, all right, let's go ahead and start with a bitboard representation that we can encapsulate inside a class or structure. So maybe we'll just have like a class board. And I'm not really sure exactly everything that we're going to have here, so I'm just going to create a setup.py, and we'll start with a board.py. All right. Not sure how we're going to construct a board to begin with, but if we want one bitboard for each piece type and color, let's go ahead and think about that. So the pieces of a board: rook, knight, bishop, queen, king, pawn. Okay, and then so we have one for each white and black in this case. So before so what would a bitboard look like? So it would be a 64-bit square. Could probably use numpy for this. 64-bit word. Basically, that looks something like this. And so the idea is that the 0th index represents sort of whichever direction however we want to represent the board. So my guess is that this will be like A1 if we look at a board. The 0th index in the bitboard word will be A1, and we go to H8 at the 64th index, or the last, the 63rd value or index in the array. So at the 0th, we have A1. And then at the end, we have H8. Does that work? Not really sure. But let's say that we want the rook bitboard. What keyboard am I using? Right now I'm using my Mac keyboard just on the laptop. I've got a mechanical keyboard that is currently hooked up to my work computer as well, which is a Code v3b that I like a lot. I think it's got browns in it. All right, so self.rook bitboard, we're just going to represent these as Python lists. Maybe we could do an NP arrays as well, but we'll start with a list just until I get my head wrapped around exactly how this is going to work. Let's do self dot white. Rook bitboard will be this. Self dot black. And so there's 7 for each. And this is just for reference. Also, I'm not 100% sure that this is exactly what they're talking about, but I'm going to go with it. It makes sense. We should be able to do bitwise and of everything and get the board out, I guess, which I suppose is one of the reasons that bitboards are used, because I suppose that is probably pretty efficient. And I imagine that if I do ultimately write a low-level chess engine, that there'll be more that needs to come into consideration here, specifically with endianness, I think. Maybe this will come up later. Hey Shanawaz, hello, and hello Arya as well. Hope everyone's doing well. Hope everyone is healthy. All right, so also challenge me to a game of chess on Lichess at username Westman if anyone wants to play chess, if anyone is a chess player, and be happy to take a break in a little while and play. All right, so we can start this out with, I think my Python is maybe a little bit rusty. Is that right? We'll keep a REPL open here just for fun. And if I say x is range 64, oops, sorry, 64, length of x is 64. All right, REPL will be in another pane. All right, so if everything is starting out as an empty list, and I'm pretty sure actually range of 64 isn't going to be a list. It's going to be a generator, right? If I'm not mistaken. X is range 64. No, maybe it is a list because we got a length out of it. Yeah, so it's a list. Sorry for jumping around here. I'm just going to clean up a little bit. Okay. All right. Why 7 and not 6? 6 types of pieces. Yeah, you're right. Rook, knight, bishop, queen, king, pawn. Sorry about that. All right, so we need the pawn, and then we need the knight. And then we need the queen. Pawn, knight, queen, rook, bishop, king. All right. Also expect almost everything that I'm working on here to be eventually completely rewritten, but till I get something that works somewhat. All right, so white, we'll change to black here. Okay, so now we've got our, hey Anten, how's it going? It's good to see you. All right, so yeah, so 0th index is A1, which is the starting position for the white rook on A1, and the other white rook is going to be at index 7. So let's just build the bitboards for the starting positions of everything, and then I'll replace these ranges with initializer functions. So let's say we want to initialize how we want to do this, because I could just have one function that says initialize pieces, which then calls init, yeah, let's call it init white, init black, that doesn't make too much sense. All right, let's just start with the simplest possible thing, and we'll start by placing the rooks on the board, the white rooks. So self.whiterook bitboard at 0 is hot, and then self.bitboard, self.whiterook bitboard at 7 is hot. Be nice to write a helper function to translate from position on in the word to position like A1, A2, etc. So I think I'm going to keep some notes up here, like function to set starting state, and then I want a function to translate from geometric to and from the word, or we'll call it a bitmap, and then also starting state function to map from geometric to bitmap, a function to, I guess it's trivial, but we want a function to bitwise and all bitmaps to get us the board state. Okay, so oh, and it would be also fun to, once we get the bitboard working, to get a function to map an FEN to board state, and well, specifically I'm referring to the state of an instance of this class in this case. And if you're unfamiliar with an FEN, here's an example of a starting FEN. In chess, it's a way to represent the state of a board using a string. And to be honest with you, I'm not really sure what an FEN, like what the rules are to construct it, Forsyth-Edwards notation. So if you're familiar at all with chess or other board games, you may also have heard of a PGN, which, yeah, here we go. And so a PGN is a data structure, or it's a standard syntax where it just provides at the top, at the header, with the headers, like a summary of the game, like its location, the players, their ELO ratings, and the result. And then it has like 1 through the number of moves, and then 1, 0 is 1 if white wins, 0 if black wins, and 1/2 if it's a draw. And an FEN is just a state of the board, and then whose turn it is, I think. And so with every position of the board, throughout a game, it's going to have a new FEN generated. So it would be nice, since we're working on the board representation, to be able to take an FEN as input and then have our stacked bitmaps come out as output. Okay. I should probably be looking at the wiki for bitboard techniques, general setwise operations. Oof. All right, so there's a lot of basic set theory, but I like that they're putting it in the context of chess. And it's going to take me a little while to, I think, get familiar with how some of the various set operations are going to be useful for us. But clearly, if we're doing bitwise representation, then the bitwise operations will be useful. Okay, well, one step at a time. Come back here. Just kind of taking a look at what else they have here. Defining bitboards. All right, so they're using unsigned integer type U64. We're working in a really high level language in Python, so okay, and then some publications. Bitboards can have a high information density. Single populated or even empty bitboards have low information density. Yep. They say they can have high information density, so the more pieces, the more bits are hot in the bitboard. Is that more information, or is it sort of the yeah, my information theory skills are pretty lacking. Bitboard often rely on bit twiddling and various optimization tricks and special instructions for certain hardware architectures. All right, so a lot of the information in this wiki looks like it's going to be really low level, which would be important for performance considerations if we were going to build something to compete with a serious chess engine like Stockfish. There is a website for chess engine ranking as well. It starts, it's like CCRS or something like that. CCRS? I can't remember what it is called. There's an acronym for it. Thanks, Albert. CCRL. Okay, so this is the chess engine ranking list. So if I keep this series going for long enough to actually understand how to build a chess engine, I'll submit it to CCRL, and we'll see how well it performs. But at the top of this list, we're going to find things like Stockfish and Komodo. Houdini's been around for a really long time. Ethereal. Slow chess must be newer. I'm actually not too familiar with slow chess unless it's just gotten really a lot better recently. Shredder, Fritz. So some of these look like they're getting overtaken by newer chess engines that I'm not familiar with. So I've heard of like Gull, Hannibal, Critter, Ribka. Ribka's been around for a long time. LC0, I'm pretty sure, is a neural net based chess engine. I think this is Leela. Is LC0 the same thing as Leela? CCRL. Yeah, there's a bit of a lag on the. Yeah, LC0 is Leela. This is super fascinating. You guys may have heard of AlphaZero, which was or is a DeepMind project, and completely different paradigm from the type of chess engine that we're building. But Leela, or LC0, is a neural network based chess engine. I have no idea how to build a standard chess engine. I barely understand so far how to do proper board representation, so I'm not going to start with a neural net based chess engine, but maybe it can be something that we look at in the future. So yeah, Leela is just getting stronger and stronger. But yeah, another famous chess engine. It's also interesting to see the different sort of styles that like AlphaZero plays with versus traditional chess engines like Stockfish. Traditionally, chess engines have really valued material um, in a really strict sense. So when you're evaluating a chess position as a human, they say like in terms of pawns are worth 1 point. Rooks are worth 5. Knights and bishops are worth approximately 3, with many people saying that bishops are worth slightly more, so let's say 3.5 or something like that. Depends on the position, whether it's open or closed or any other concrete details. And then a queen is worth like 9. And so traditionally, chess engines have been really materialistic and evaluated positions really concretely. And then with the emergence of some of these engines like Leela or LC0, and then certainly AlphaZero, there's a great paper from a few years ago showing some AlphaZero games. AlphaZero effectively taught itself how to play chess by it basically started with the rules and nothing else. There was no sort of evaluation heuristics built into the engine, and in playing itself, it quickly became like immensely strong and was even able to beat Stockfish in a match of, I don't know how many games it played against Stockfish, but maybe like 100 in the paper or something like that. Um, and it played in a way that was much less materialistic. So there were some really fascinating games where it sort of played in what people would say an almost like romantic style, like a bygone era of chess where material isn't as highly valued um, as many modern chess engines evaluate it to be. So it played much more positionally, and it's just really fascinating. So, but I'll be lucky if my chess engine can, or if we can even represent the board anytime soon. But kind of off on a tangent here. All right, so let's keep the board open. We're going to work on setting up our boards. All right, and the notes that I have, yeah, look good. Map FEN to board state and vice versa. So right now we're just starting to set the starting state. So white rook is here, self dot black rook, bitboard is going to be at position, what? Oh gosh, I'll get there. Let's start with the white pieces. Self dot white knight. Bitboard is going to be position 1 and position 6. And then we'll have the bishop position 2 and position 5. And then the king at position 4. Queen at position 3. So black rook is going to be at position 63. And what is this going to be? 50. So 63 to 160, 59, 58, 756. And then the knight at position 57. And 62. 61 for the bishop. And 58. Yeah, Ivan, that actually makes a lot more sense. I wouldn't have had to count if I just, yeah, if I just did it that way. All right, so we got the bishops. Now let's put the queen. The black queen is going to be on 59. I'll adjust it if I miscounted here anyway. King is on 60. And now do we have everything? So we've got the, well, we need to put the pawns on, obviously. And just in terms of like human terminology, I'm not sure how human terminology, in terms of chess player terminology, typically people don't call the pawns pieces, but these would be, the back rank would be the pieces. Your minor pieces would be like your knight and bishop, and then you have your rooks, and then the queen, obviously. And as I mentioned, they would typically have a material value associated with them in terms of number of pawns. And when you look at chess engine evaluation, so if we turn Stockfish on here and we take a look at starting position, typically it's people say that white has a slight advantage at the beginning of a chess game because white gets to make the first move. So in that sense, white has the initiative. And at really high level games, it's really up to black to equalize before black can consider trying to get an advantage. Because first black has to stop white's initiative. White is the player that gets to start. And so you'll see a slight advantage for white by Stockfish. This would be 3 center pawns, so just a really minor advantage. But if we just play a standard opening here, um, so this would be the Italian game if we play like this. And it'd be nice if it didn't recommend moves, but I'm not sure exactly how to turn that off. But yeah, we'll play sort of a standard opening here. And you'll see in these sort of standard, well-known openings that there's been a lot of theory about many different chess openings for hundreds of years. This is an opening called the Italian. Specifically, I think this is the Giocho Piano. But you can see that Stockfish is giving a 0 evaluation. What that means is that both sides are approximately equal. And if we, like, let's say we make a blunder, I don't know, we play a move like this, and this hangs a pawn. So we can see that white can take a pawn here without black being able to recapture. And already Stockfish gives white a plus 2.1 advantage or plus 2 advantage. And so what that means is it's effectively equivalent to white having 2 extra pawns. So this evaluation is typically measured in terms of pawns. Now, even though black only lost 1 pawn here, Stockfish is really evaluating like positionally. Don't think of pawns like totally concretely here. It's just a general measure of quality of the position. So it's telling black that the best move for him is to probably move back. And if you're in a position like this as black and you've already had to move your pieces more than once, then things aren't looking good. So black's lost a center pawn here, a central pawn, and white has a lot of initiative. And so, yeah, that's just a quick overview of what a typical chess engine evaluation would look like. If we go back and instead of playing that move, and let's say that white blunders for some reason, like let's say that white plays like a move like this and clearly blunders its bishop in a number of different ways, you can see that the evaluation is now minus, in this case, 5.1. So this is saying that black is effectively winning and white has a losing position. So in this case, white's given up a piece and clearly it's black to win the game here. And so if black's winning, the greater the negative value, the more negative the value, the more winning the black position is, and the more positive the value, the more winning the white position is. Anton, could I make an in-depth tutorial on Vim? Yes, I started a tutorial series on Vim for my productive dev stuff, and I just haven't finished it. But yeah, I could definitely do that. If you want to learn Vim on your own before I get done making that series, you could run Vim Tutor, um, which is if you haven't heard of it, it's sort of like it's effectively just a text file that sort of works you step by step, and it kind of like starts with basic navigation, cursor navigation, and then works through different types of editing and working with files and things. But it's a good way to get started with Vim if you're just learning. All right, I'm going to turn Stockfish off because it is making my fan spin just a little bit. All right, so yeah, and like I said, if anyone wants to play chess, just challenge me on Lead Chess, and I'll take a break in a little while and do this. All right, so we've initialized our pieces so that we're setting hot bits for the starting position of every piece, and I need to do the pawns now as well. So we start out, each side starts out with 8 pawns, obviously. So here, so for I in range, I always forget in Python, self dot white pawn bitboard at I is equal to 8, and this is going to be starting at position 8 and going up to position 15, I guess. Is that right? So if we did so if I wanted to do 4, 8, so that is equal to x. So it's 4, 5, 6, 7, 8. Yeah, so it starts there. So this would be 8, 15, so that should be right. And then we'll set black's pieces as well. So white, black. Okay. All right, so if I'm not mistaken, which may very well be, we have set up the boards for all of the pieces. Could do, yeah, I'll clean this up and make it a little more concise here in a little bit. So if we want to make a new board, what I'm going to do is open up a new pane here, and I'm just going to make a scratch.py file. Actually, you know what I'm going to do is forget that. I'm just going to come back here, and we'll go into the this stacked. By the way, if anyone watches the channel, this will be the next series that I mentioned in the that I mentioned recently, which will be a CMS using .NET 5 on the back end and Vue on the front end. All right, so let's move into calling this chess engine wake, and yeah. All right, so let's start here. From board, import board. B is equal to board. I guess that to interact with pgan, you'll need a conversion function for the movements themselves into the position node. For instance, if you want to represent FIDE games, you mean? Yeah. Yeah, so we'll need to be able to, I guess, like iterate over a PGN and represent that as like a stack of moves or something like that. I think a stack's probably a good data structure because we could represent going forward and backward in the series by popping from the stack or adding to it, similar to like say browser history, I guess. All right, so we have a board representation, and if I do b dot, what do I have on this? Oh, I didn't even call init pieces. Maybe I should open up a Jupyter notebook in this directory. And I'll start a Git repo here as well. What's the Jupyter file that you should ignore? IPyNB, something like that. I can't remember what it's called. And we'll ignore the PyC files as well. All right, so let's pop open Jupyter. I can't remember which one of these kernels has. Doesn't really matter. We don't have any dependencies. So, all right. So we'll say from board import board, and then we can say board dot. What do I have on this? Is it smart enough to pick it up? White pawns bitboard. Oh, kernel error. What's happening? Let's try to change the kernel to Python 3, I guess. Yeah. All right. So board is a new board. Init pieces takes. What did I mess up here? All right. So there we go. Do I have to restart the kernel to reload? Yeah. All right. So range object does not support item assignment. All right. So what we're going to do is, I guess we need to make all of these lists. And I want to initialize them with zeros as well. So I don't believe I didn't even think of that. So let's do def create empty bitmap. I realize that these don't need to be instance methods like this, but return 0 for in range 64. I think that works. Yeah, so we're going to create this massive list for each. Well, not massive, but and then I'll just replace all of these. Range 64 with self.create empty bitmap. And then I'll replace all the 64s because I didn't do that by accident. All right, so let's try to restart the kernel and run again. And this all needs to be self. I wish I had hot reloading on the Jupyter. I'm really surprised that re-importing doesn't actually reset it, but all right, so All right, so there's our white rook bitboard, for instance. So actually, I've been asking to 64 times list 0 work. Yeah, that should work as well. So like if we were to do what, or Ivan is, sorry, if Ivan suggested doing something like this, which would also definitely work. And I like it because it's more terse. Okay. So now actually if we do a bitwise AND of all of the bitboards, we get the board state. So that should be our function to get the starting state. And so what we can do is bitwise AND everything. And just do it like this. Okay. So I think that should work. And then maybe we can pretty print it as well. We can write a function so that it looks like so I guess I'm kind of thinking, so this is a piece-centric representation. So the idea isn't that like if I bitwise and all these together, the only information I'm getting is whether or not a square is occupied. We're not getting any additional information about what's occupying a square. We're just getting a vector with certain indices hot and others 0. So it'd be interesting to try to figure out from this how we determine like what legal moves are. Okay, well, we'll get to that point. So we're going to run our methods again. White rook, this should work. And so now if we do board.get bitboard state, unsupported types for and list and list, bitwise and lists. Oh, they need to be sets, right? Yeah, they should be sets. But then I can't. Access their elements by index. Using reduce with the lambda and the bitwise and operator. Works only with Python too. What about numpy bitwise and array? All right, I think we're going to use numpy. So if we do numpy zeros, and we'll do dtype bit type numpy. import numpy is np. We could just use a really small one. I shouldn't even really be concerned with performance at all at this point, but I want to know, like, if we have a Boolean type that's a bit, maybe stored as a byte. So maybe that's as small as we get with numpy. It doesn't really matter. All right, so create empty bitmap is going to return us np.zeros. Oh, also I have a Vim plugin for documentation that takes a while to load sometimes. All right, so zeros. And clearly this needs to be 64. And so with numpy, we should be able to do a bitwise, and with all of our arrays. So I think what I'm going to do here is, was I passing the whole time? That's hilarious. All right. So self.bitboards is equal to np array all of these. I see. Thanks, Ivan. That makes sense. So with numpy, so basically I have a numpy matrix here. If I do an array of numpy arrays, each one of these is going to be initialized as a 0 vector, and then of length 64, and then when we initialize our pieces, this syntax still works for us. We can index into the numpy array like this. But now I'm just trying to think of, do I want to have an array that stores these arrays so then I can have that as sort of the unit that I work with. Then I hopefully there's some way I can call bitwise and on a two-dimensional array. Numpy bitwise and 2D array. Well, let's just check it out here. Actually, we should just be able to test this one out. Import numpy as np, and then let's say we have x is np.zeros, just do 8, y is np.zeros 8, and then let's just say x at 1 is equal to 1, x 2 is equal to 1, y at 0 is equal to 1, and y at 1 is equal to 0. So if we do z is x and y, where is our bitwise and? It's just np bitwise and x1, x2. Alright, so if I do np dot bitwise and of x and y, I get that this is okay. Efunc bitwise and not supported for the input types, and inputs cannot be safely coerced. So these are two numpy arrays of the same size. So let's read the docs here and see what I'm doing wrong. Array like, only integer and Boolean types are handled. Oh, okay. So and hmm? It's a little bit confused by that error because I thought, like, what's the difference? What if these weren't numpy arrays? It said they had to be array like. If I bitwise and 1, 2, 3, it's Python lists. So this works, but numpy arrays don't? How is that possible? No, that works. So what did I do wrong? That's so confusing to me. Why can it not bitwise and these two arrays together? I don't understand. Not supported for the input types. Inputs cannot be safely coerced to any supported types. Okay, so I just have to explicitly set the types as byte, I guess. Okay, so when we do bitwise and these, yeah, okay, so that works. Exactly. So it's bitwise or that we want to get the board state, right? That makes sense. What would bitwise and represent in this case? Bitwise and would get us like on a move capture, because it would be when two pieces occupy the same square. So bitwise and from the perspective of, oh, I think some things are starting to click now. We have to think piece-centrically, which is why they call this a piece-centric board representation. So if I were to bitwise and any of like the white pieces together, any of the white bitboards together, and I have anything but a zero vector, then we have an illegal move situation, because it would mean that two white pieces occupy the same position in the board. But if I bitwise and all blacks bitboards with all of whites bitboards, we get the captures that have happened for a given move, because it would be where one of the other pieces occupy the state, and we know that from any given state it's either white or black's turn, so we would also know whether or not it was a white or black capture. Aha. Man, whoever came up with bitboards as a data structure to use for this is really smart, and I still don't even completely understand all of the implications, but that's really cool. So we want a bitwise or stuff. Why did I say bitwise and? We want a bitwise or to get the board state, and my hunch is that bitwise and, all right, this is my stuff to do up here, and then down here are just my thoughts. Function to bitwise and, this looks like this is getting piece captures, illegal moves, etc. This would be if we had homogeneous, and this would be if we had heterogeneous. Yeah, that's pretty cool. That will be interesting. So I'm excited to see how that works. All right, so we got to come back here. So when we want to do this, wonder if I can do, so z is like this. What happens if I do np.bitwise and? Does this reduce into a single vector? That would be really sweet if it did. No. So we want to reduce over every bitboard and it numpy reduce bitwise or reduction of bitwise and use functions equivalent to for I in range length A. All right, so I guess we have to do it something like that. So what I'm going to do is on the state here, I'm going to add all of the bitboards to one global bitboard, one global array of bitboards called self.bitboards, numpy array of the following self.whiterook bitboard, night. Did anyone challenge me? I would love to play somebody at chess in a few minutes if anyone's up for it. Bishop, queen, king, and then white to black. Okay, so yeah, whatever. All right, so there's our so now if I want to get the bitboard state for board in range length self.bitboards board, how are we going to do this? Numpy logical XOR and bitwise XOR works. Is there a Alright, so let's see. np.bitwise or z. I thought it just said that it works for 2D arrays. Random choice b. Oh, it's just, I see. Two-dimensional arrays. Numpy, bitwise, or a matrix. I'm sure that there is a a function that takes a single argument to do this, I think. Yeah, it's not bit packing. So do we just loop through all of the bitboards on the instance? Bitwise or each of them? Does that work? Should work. Because every time we see a new one, we'll just put one in that spot. That wouldn't work for an and, right? I don't know. Okay. So get bitboard state would bitwise or everything. The other cool thing is that it's relatively inexpensive to add a new bitboard that represents some other state, and there are other states that we might be interested in representing, I would imagine. So like right now we're representing one bitboard for each of the 6 pieces that either side has. We also might want to store bitboards for quick evaluation of other properties like empty squares. No, wait. Maybe empty squares. I wonder if we use bitboards for other things like legal moves for each piece type. I don't know. It'll be interesting to see. But I guess my point is that it feels like it's a relatively terse representation. Well, like the article said, like potentially information dense, but it's a really it's really concise. Yeah, they can have high information density. They're weak in answering questions like what piece, if any, resides on square X. One reason to keep a redundant mailbox board representation with some additional update cost during make on make. That makes sense. In order to answer a question like what piece resides on square X, if we had a square-centric representation, we could just index immediately to that square and look at some value that's stored there. But with bitboards, we first have to look at every bitboard until we find the answer to that question. So at most, that would always be O of n, where n is where n is in this case 12 because we have 12 bitboards, right? Yeah. Bitboards are rather handicapped on 32-bit processors as each bitwise computation must be split into 2 or more instructions. All right, so that's a little bit out of my pay grade at this point. I have no idea. But that'll be interesting to learn more about. Bitwise often rely on bit twiddling and various optimization tricks and special instructions for certain hardware architectures, such as bit scan and population count. Again, I'm not really up on the low level stuff, so I don't really understand the implications yet. Some operations on bitboards are less general. This requires additional code overhead. All right, well, once again, we're writing the initial version of this in Python, and so basically all of this is abstracted away from us that we don't really have much control over at this point. But these top 3 points still hold and are very interesting. All right, so let's go ahead and save that. Let's determine if I have any other bugs before we continue. So come back here. Board object has no attribute white rook bitboard. I gotta initialize this down here. Alvaro says it means you'll have a bitmap piece-centric for calculation and then a physical representation board-centric at the same time for querying and drawing. I think that's what I'm understanding it to be. So like it makes sense, I guess, to have a square-centric board representation for answering questions efficiently, like what's on square A1 or what piece is on square E5. So we don't have to look through all of the bitboards to determine the answer to that question because we have 64 times 12 bitboards. Whereas if we have a 64 position array or whatever, some vector that just represents, we can immediately just go to the index represented by E5 and then look at the information there to determine what's on that square. So your question is a board centric at the same time for querying and drawing. So that's, yeah, so for querying questions like what's on E5, I think that board centric is going to be more efficient. That seems to be what they're saying. And then P centric for calculation, I think that's true. Because it looks to me like the operations that we'll be able to do with bitboards efficiently. So things like bitwise operations to determine things like piece captures can happen immediately, or trivially anyway. Like we can basically just take a bitwise and of everything, of all of the bitboards to get piece captures, because we'll get ones where there are piece captures, and then if we look only at homogeneous sets like the per color, let's say, like I guess this isn't really the best terminology that I'm using here, like piece captures for different color ands, and this one would be like for the same color ands. To me, that looks like that's going to represent illegal moves, for instance, because if we bitwise and all of the same color bitboards together for the pieces, anywhere where there's a 1, that's 2 pieces on the same square, and that would be an illegal move. I'm just totally winging it, but that's my guess at one simple application of these bitboards. It's going to be really fascinating to see how like evaluation works and search. I know that chess engines have like horizons, so they can basically look a certain number of plies ahead before they lose information. I think there's just like an immense amount of um, optimization that goes into pruning those search trees, but I don't know anything about it. So, all right, I'm gonna play a 5-minute game before I get back to. Well, let's just make sure this works, and then I'll play a 5-minute game. All right, array takes from 1 to 2 position arguments, but 10 were given. Oh gosh. My numpy skills are extraordinarily rusty. Bitboard says np.array. Oh, I can't initialize an array with a bunch of these, so yeah, we'll look at that in a minute. np initialize 2D array with other arrays. Somebody challenged me? Oh, I got a challenge. Nice. Is this someone from the chat, or is this just Alright, so I'm gonna play the Karukan. Did anyone watch Queen's Gambit on Netflix by chance? They kind of make fun of the. They don't make fun, but they say the Karukan opening is all pawns and no something. I forget, but anyway. Thanks for making a game with increment as well. Alright, well that's. I'm gonna look at this. Ooh, what happened here? Alright, so if I just take back trying to see if, yeah, I'm not gonna give him another central pawn. All right. So how do we initialize a numpy array of arrays? numpy.concatenate a1, a2, a3. So I think if I call that over here, we'll do that. That'll be fine. We'll do that in a little bit. Castles already. All right. Yeah, my position's already a little cramped, but that's the Caro-Kann, I guess. This person has a provisional rating, so I don't know really how strong they are, but I think you start out with a 1500 rating, so. H6 might be a weakening move, since I'm probably going to try to castle kingside, but it's basically to try to prevent knight g5 or bishop g5. So my position's kind of cramped, and my pieces are much less active. But I am up a pawn, and white doesn't have any center pawns, but he's got a rook already on semi-open file, and all of white's pieces are really active. So he'll probably bring out his dark squared bishop now, and he's probably going to put it on f4. Oh, okay, so he wants to trade knights. Alright, so knight takes e5, rook takes e5. Knight takes e5, rook takes e5, queen c7, rook goes somewhere. Where does he want to put the rook? In that case, the rook doesn't have any squares on the 5th, so maybe the rook has to go back to... If I were him after this, I'd probably just put the rook back on e1. My guess is he goes rook e1. Oh, this just hangs a queen, right? So what am I missing? Okay, so... Alright, so definitely winning at this point. Let's just try to simplify. Iran says, how do you resign? You click the flag. If you want to resign. Doesn't matter to me. GG. Alright. I'll offer a rematch. If he doesn't want to play or they don't want to play, I'll play someone else. Play one more game before I get back to the bitboards. Alright, so let's play their game. Mouse slip. Yeah, that definitely happens. Alright, they're re-challenging me, so I'll play another one. So I'm an e4 player. He's going to play a Pierce, I guess. Alright, so he likes to trade queens early. So this is probably much better for white because now white has lost the right to castle. And I could also double black's pawns here by taking on c6. But I think I'd like to keep the bishop around. I'm just going to play slower. Yeah, now he prevents me from being able to double his pawns by playing knight d7 because he could take back with the knight after bishop takes c6. I'm going to tuck my bishop away here. And now I suppose that his idea is to... If I were him, I'd probably be looking at playing bishop g4. I'm not sure what the knight is doing here. I guess it's just getting out of the way of the bishop so that he can put a bishop on a more active diagonal. So I'm just going to take the open file with my rook. And just continue to develop some pieces. So my idea is to... So what's my idea? I mean, I haven't developed the knight on b1, so I can reroute the knight on b1 to... See, I kind of thought... Let me just think here for a second. I don't know. If anything, I'm just going to play a prophylactic move and keep his light squared bishop off of the g4 square where it would pin my knight against the rook. And then I'll play knight d2 on the next move, with the idea of knight b3 and then something like bishop c5. Try to get this file opened up against his king. So his king's really not safe in the middle of the board right now, and it's also lost castling rights. So it can't find a safe square, say, on the queen side where it might like to be. All right, so he brings his knight back to d7, saying that basically, I guess his idea was to get the dark squared bishop free. But I think that this is probably a little bit slow. But I think the position's probably only slightly better for white. Black's getting a lot more space, and now he's trying to break open the center with f5, but I kind of feel like his king might be a little too weak for this, is my guess. So for one thing, I could try to put my bishop on g5. He could then immediately play h6, at which point I would have to probably take his knight, because otherwise if he plays h6 and then I play bishop h4, he can then play g5, and so he's got this pawn storm coming down on the king side. My king's not particularly safe there, so my other idea is to ignore this for the time being, play knight b3 with the idea to continue my plan by putting the bishop on c5. I suspect that after I play knight b3, he's going to play f4, at which point my bishop just immediately goes to c5. I think he's really trying to put the pressure on the king side here, so I'm guessing he's going to play f4. If he takes, I don't think takes is a big threat. It just improves the position of my light squared bishop. So I'll play bishop takes e4, pinning the knight against. All right, so now we're going to play the plan. If he had taken, I would have played bishop e4, the knight's pinned, and maybe I could have even gotten away with playing knight g5 there with the threat of knight f7, forking either king and bishop and winning a pawn, or forking king and rook and winning a rook. So here I'm just going to pre-move. I think he's in some trouble here if he takes, because this, I think, would win the bishop, the light squared bishop, because if he takes and I play knight takes c5, the light squared bishop is hanging because it's pinned. Alright, so while that's going, I'm also going to be coding it. Alright, so now I think he's in some trouble. So is it np.concat or np. What's the actual syntax here? np.concatenate. And then is it a list of, it's a sequence of array like, so it's np.concatenate a b. Yeah, so alright, so now my opponent has lost a bishop. He'll probably play rook d8, which he does. The problem with rook d8 is I can just move to safety here. So I'm pretty sure like if I play knight takes e5, if rook takes, if knight takes e5 after knight takes e5, I play knight takes knight on e5. And so I think here I'm just also winning a pawn in addition to the bishop. So if he takes the rook, I'll just pre-move. If he takes the knight, I will take back with my knight. Actually, if he takes the knight, I'll play rook takes d8 check first and then retake with the knight. Alright, and while he's thinking about that, it looks like I need to have, it looks like they had this as a tuple, if I'm not mistaken. Like this. Alright, so yeah. So not looking too good for my opponent in this position. I am up a bishop and a pawn, and his knight doesn't have very many good squares. So he'll probably play, I mean, if he doesn't play knight g8, he's going to play knight c6, at which point I take, king takes, and then rook takes g7. And I'm just picking up a bunch of pawns, and I'll start marching my king to the center. And in either case, probably put the rook back on d7. Okay, so that's probably not a bad move. The knight currently keeps the king off of c6, but it doesn't keep it off of c8. I can kind of harass this rook though. Alright, so how do I want to handle this? I think I'm going to try to trick my opponent. So the pawn's protected by my bishop right now, but I'll probably reinforce it with f3 just to prevent my opponent playing f3. So I should have a winning position here. Now I just need to make sure I don't blunder. Alright, so does NP concatenate work like this? We're going to come back here. Every time I move away from the board, my opponent plays restart and clear output. Okay, so here I was hoping my opponent would play something like this. So now I can force the trade of rooks because I'm going to play knight d6 check, forking the king and the rook, and he can't take back with the pawn because he's pinned. He'll probably play king c8, which point I'll play knight takes e8, threatening the pawn on g7. But the idea is just now that I've forced the exchange of rooks. So he can't play c takes because he's pinned. Oh, and he also can't play c8 because my knight was on d6. So I actually missed that. So actually this just wins a rook. All right, so now I'm just sweeping up some of the remaining pieces. All right, good game. Thanks for the games. All right, I'm not sure if that was someone who was watching the live stream or not, but anyway, that was fun to get a break. If anyone else wants to play at any point, just challenge me. All right, so we'll come back here, figure out how the board representation is going. So we don't need any of the numpy around anymore. It's like the board initialized fine, at least without errors. So now we're going to see what's on the board. We can see what's on the board, I think, with this. And it looks like we have a bunch of bitboards. This bitboards array is everything concatenated, but it's concatenated before we actually init everything. So we'll init the pieces, and then when we want to get the bitboard state, well, actually that's fine. So like we just set self.bitboards here. So what we can do is we can say self.bitboards is equal to result. Cool. All right, so let's go ahead and restart. So bitboards are going to help us answer questions like, well, at the moment, they'll help us answer questions like what squares are white pieces on, what squares are black pieces on, what squares are white pawns on, that sort of thing. All right, so here we go. I didn't realize my cat was in here. All right, so he's been locked in here for a while, I guess. All right, so there we go. So now if we want to get the bitboard state, we can say get bitboard state. And all right, bitwise OR is not supported for the input types, and that's because we saw that we actually have to do the D type here of, what did I do? Byte. And thanks to Ivan for pointing it out earlier that that's obviously the smallest amount of memory that can be allocated, so that we can't represent it strictly speaking as a bit. Is there a way? np.zeros. Yeah, here we go. D type is byte. All right, so let's restart. No loop matching the specified signature and casting was found for function bitwise OR. No loop matching the specified. That's a new one. Oh. I don't think it's the bitwise OR that needs the D type. I think that once I initialize the arrays as bitwise OR, not supported for the input types. Result is equal to n bitwise OR. At least I'll know a little bit more numpy by the time this is all said and done. Numpy bitwise OR D type. D type float. Can you not do this loop with a D type byte? Did I just spell it wrong? Nope. No loop matching specified signature and casting was found. Salt is self.bitboards. Create empty bitmap, self.queen.bitboard. Create empty bitmap. So all these should be byte types, numpy byte types. Hey, Mr. Tubber, working at NASA. Yeah, right. but it's good to see you. Alright, as soon as I figure out this bug, I'm going to play another couple more rounds of chess. What else do we got to have done in this file, though? So we're representing him as numpy arrays in this case. And we have a function to set our starting state. We have starting state, except that this get bitboard state function, our method isn't actually working with the bitwise OR operation on everything. Appreciate you too, Mr. Tubber. Function to map from geometric to bitmap. Yeah, so this would be the next thing that we do, though, after I get the starting state set up, is a way to say, if you say A4, like that we'll have a function that maps from the geometric notation to bitmap notation. Although that almost implies that we should also just make the board-centric representation. So I have to think about that. All right, so let's just make sure that this this bitwise OR in a loop actually works. So why doesn't this work? So we'll import numpy as np, and let's say I shouldn't have deleted all of that. So x is an np array, and here let's say we have some array. Y is the same. I wish there was a Vim, or maybe there is a Vim plugin for Jupyter, but I'm not aware of it. Let's just do something a little bit simpler here. 0, 1, 1, 0, 0, 1. And then z is np.concatenate x, y. And this needs to be an array like. All right, so now we've got z. Oh, it's not concatenate that I want. Oof, it's do I need to specify the axes here? Axis is 1. Axis is 0. It's not array concatenation that I want. It's obviously it's not array concatenation that I want. Numpy create n-dimensional array from arrays. Here, create 2-dimensional array from multiple vectors. np.vstack? Really? vstack got it on axis. Yeah, we don't want that. Okay, so that's what I want. np.vstack. Sorry for hitting the mic. All right, so rather than concatenate, np.vstack. Hopefully that works, and then we can be then maybe our bitwise OR works here. Concatenate presumably changed the type. Really? That's interesting too. I mean, it was my fault for using the wrong operation, but does concat, let's say I make this a d type of byte. D type of byte, if I can spell. First of all, let's do int 8. Hopefully int 8 works for a bitwise OR. All right, so what if we did byte byte, and then what if we did our concat? Concatenate. This also changes it to int 8 numpy int 8 versus byte. Maybe it's just signed char in C versus C type as int 8. So this is a byte minus 128 to 127. Byte is just platform defined, so maybe it's the same. P int 8 versus byte. Okay, well, I guess we're just worried about the general sketch before it moves to another language anyway. All right, let's see if this, now I'm kind of worried that the bitwise OR won't work, but we can try. No loop matching specified signature and casting was found. All right, let's change all of this byte stuff to an int 8. Kernel restart and clear output. Hope everyone's doing well. Up here in Wisconsin, where the COVID numbers are looking pretty bad still, but I'm doing well here, so that's good. No loop matching the specified signature and casting was found. Ufunc bitwise OR. That's frustrating. So what did we find when we came here earlier? When the matrix is created, so np.matrix, hopefully this works. Bitwise OR dtype int 8. I make my empty bitmaps this way as well. What if I specify it as a larger type? Is it just not defined for the smaller types? It seems like it would be, especially since it's a bitwise operation. Yeah, so that's not the case. Likewise, if I change this to float, we'll figure this out. This should be like the easiest part. Numpy pains. Yeah, okay, we'll figure this out in just a moment. Where is the analysis board as well? If anyone wants to play, just challenge me to a game. I'll be right back. Gotta run to the bathroom real quick. Thanks for watching, by the way. Hey, Zokir from Uzbekistan. Thanks for watching. There's a bit of a lag, by the way, between the chat and the video, so apologies if I'm slow to respond. I want to figure out this numpy error before I play another game of chess. So let's see. The problem is no loop matching the specified signature and casting. This is happening in our get bitboard state when I'm trying to call np.bitwise OR for board and result. So one thing that I can do here is, what's up, Sidhan? All right, so one thing I can do here is basically I can print Is it trying to bitwise OR two things that are of different types? For board in range. Oh, I'm an idiot. I am saying I just need to do for board and bitboards, right? For board and bitboards, bitwise OR the board and the result. Oh man. Alright, so now instead of floats, I'm going to move this back. I think I just needed to like get up from the computer for a second, which is no surprise. Alright, so I'm an idiot. I don't know if that should certainly at least fix something that was completely wrong. Well, we still have a problem here. For self and bitboards, result is equal to np bitwise or board results. Okay, and then I think this numpy of zeros is the other problem. This needs to be a byte as well. Kernel restarting clear. By byte, I mean the elements of the numpy array need to be the same type. All right, so that's a really good call, Sidhan. I should push to GitHub, so I'll do that here in just a moment. Actually, let me do that on my other monitor. It looks like we got our bitboard state, by the way. So if I do like state is equal to board.get state, let's go ahead and get rid of the numpy stuff. And we do state. What is our state? Why didn't it return? Oh, it's just setting. So if I say, rather than get bitboard state, I could either return it. This is basically setting the bitboard state. So maybe what I can do is say self.bitboards is equal to the results and then return it for the time being. I'm a little sleepy, so apologies if this is complete nonsense. So basically I'm setting the bitboard anytime get bitboard state is called. Probably we would want to set the bitboard state at each turn, so there needs to be a way to say update bitboard state. So what I'll do is I'll make this explicit. We'll have an update bitboard state, and then we can access the bitboard state itself just on the instance by calling self.bitboards. All right, so we'll go ahead and call this one board.update bitboard state. Kernel, restart, and clear output. While that's going on, I'll set up the GitHub repo. Thanks, Sidhant, for mentioning that. And by the way, thank you guys for joining me. This series will probably be kind of a slow burn. So for anyone who's joining recently, I'm working on building a chess engine, and right now we're working on building up the board state. I've never built a chess engine before, but I've played a bit of chess and have always wanted to try my hand at building an engine. If I can figure it out, and if it remains fun for long enough, then I will. The goal is ultimately to submit it to CCRL and try to get on not this CCRL, but this CCRL, where you can submit your chess engine and see it on this list. There's a lot of really, really strong chess engines on here, and I don't really hope to be able to compete with any serious chess engines anytime soon. But I would like to make a chess engine just for fun. All right. And it's going to be a traditional chess engine, but it might be fun to look at what is entailed in in building a neural network-based chess engine like Lichess or LC0 Lichess. When I say Lichess, I'm so tired. Leela. All right, so we have a function to set our starting state, function to bitwise OR everything. That does get us our board state. Function to map FEN to board state. That'll be something we can do. Although I think that will be better with a board-centric representation than a piece-centric representation like bitboards. Alvaro. Oh, that was you. I was playing Alvaro. Good game. Yeah, I used to play more. I used to take it more seriously, I should say, but a lot of hours waste. You could argue are just wasted. That I've wasted playing chess, but good games. Did I try playing chess on chess.com? Yeah, I do play chess on chess.com as well. If anyone's on there and wants to play, I'll play there as well. I think my username there is, it's just West Doyle, and you can find me there. But if anyone does want to play, I would challenge to like a 3 or a 5 minute game. Building projects like this are very amazing. I wouldn't say that this project is amazing yet, but it would be amazing if we could keep it going. All right, so yeah, we can build a function a bitwise and, which is the idea for, we could potentially use this for piece captures or legal moves. I just have this feeling that we need to build a board-centric representation, although I don't know if that makes total sense. I think my mind naturally sort of thinks in board-centric representation. I think everyone's does because we look at a board. This piece-centric notation with these bitboard representations, though, do make a lot of sense because we can sort of immediately see how easy it is to get certain information out using bitwise operations. So we'll work on that next. So what happens next? Okay, bitboard operations. Let's go to the start. Okay, hybrid solutions. And this was something I was talking with Alvaro about earlier when we were kind of trying to figure out, like, do we need both, or like which one is more efficient for which one is more efficient for answering certain questions versus another. So like it seems like this piece-centric notation, this bitboard notation, is really useful for potentially for certain types of calculation. And the board-centric notation's useful for, yeah, drawing is one thing, and querying the board, like what piece is on C4, for instance, those types of questions. All right, so let's see what else we have here. Where's our chess programming? Yeah, so piece-centric keeps list arrays, sets of all pieces still on the board. That's our bitboards. Keep this open in another tab. Square-centric, I think it's called mailbox because, yeah, clearly it's sort of like a collection of mailboxes with slots. I think that they basically, they also do this larger board size, I think, to make things simpler for calculating like out of bounds stuff like knights. Yeah, here we go. So here's an example of different knight moves, some of which are going out of bounds. And I like that this wiki uses examples from these legacy chess programs. 120 byte array as a board. In a certain sense, I'm thankful that I'm not required to think about how much memory my system has in order to play chess. Although I'd probably have a much deeper understanding of it if I did have to work within those constraints. So here's a mailbox representation. We need to figure out which pieces can go where. So let's say that we have a rook on square A4, and we want to know if it can move one square to the left. So we subtract 1 and we get 31. So A4 would be, in this representation, this square here. So A1, 2, 3, 4. And if we subtract 1, we get 31. The rook obviously can't move to H5, but we don't know that without doing a lot of annoying work. Yeah, because it would be like mod, you'd have to like mod to determine if you're at the beginning of a row or not, I guess. So if you have this representation and you minus 1, you always get the value -1, which tells you that it's an illegal move. So we figure out A4's mailbox number, which is 61. I see. Subtract 1 from 61 and see where mailbox 60 is. In this case, it's a -1, so it's out of bounds and we can forget it. I see. The offset move generation code, testing if a square is on the board, looks as follows. Side to move, the side not to move. Okay, well, we're not quite doing board representation at this time, or we're not doing board-centric representation. We're still doing piece-centric, square-centric. I keep saying board-centric. And then there's this hybrid solutions. So it's quite common to use redundant board representations with elements of both. Bitboard approaches often keep an 8x8 board to determine a piece by square. So we could keep that with our representation, while square-centric board array approaches typically keep piece lists and or piece sets to avoid scanning the board for move generation purposes. With a board representation, one consideration is the generation of moves. So I think we can start thinking about this now. By the way, if we come back here and if I saved it properly, we've updated the board state. And now if we say board.bitboards, okay, we still have an array of zeros. Dun, 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 dun. So did this not work when we iterated? So for board and self.bitboards, okay, so what I'm going to do is just to do some debugging here. We call init pieces after the initial self.bitboard is set. Let's init the pieces here. So kernel restart, clear output. Yeah, so there's our starting chessboard. It looks like we might have a bug because I have a 0 in one spot. So maybe we have a typo somewhere. Let's do a way to pretty print the bitboards. So if we do def pretty print bitboard self, we'll just do pretty print, and what we can say here is something like okay, so how do we want this to look? Now this isn't actually like, this doesn't have information. What we could get the information, but this is just about whether or not a square is hot or not, whether or not it's occupied. So what we can say is for square in self.bitboards, and I think I want to call this like state, but for the time being we'll call it bitboards, especially if we have an alternative representation in the same class. All right, so for square in self.bitboards, we could do I square in length, sorry, in enumerate self.bitboards if I mod 8, sorry, if not I mod 8, print, we'll say val is equal to this, val plus equals new line, and then we'll say val plus equals x, we'll say, sorry, if square val plus equals x, And I could continue here or do an if else. We'll say val plus equals this. Alright, I'm totally kind of winging that, but we'll see. It's probably going to look ugly. Board.pretty print. Yeah, that looks really ugly. That's because I put the val inside of the for loop. And there you have it. Alright, so clearly still have some mistakes, and that's alright. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So it looks like we're missing a... Also, this is going to be white at the bottom, so we need to flip this as well. But that's okay. We're also just missing the white... Is that going to be a white queen? White king, actually? Where's the white king? White rooks, white knights, white bishops, white queen. Yeah, white king's on the wrong square, so the white king needs to be on 5. So kernel, restart and clear output. Also, we're missing all of our pawns. For I in range 8 to 15, self.white pawn bitboard at I is equal to 1. Alright, so we have some pawn bugs. Also, why didn't this work? Was it the black thing that I messed up? No, that looks right. Okay. Kernel restart and run all. Alright, why is the black or the white king still missing? 1, 2, 3 now, obviously. Alright, rook, knight, bishop. I need queen on 3, king on 4, bishop on 5, knight on 6, and rook on 7. Oh man, why did I mess up? 1, 2, 3. Alright, so that's all good. Now we need to see why the pawns aren't being added. So for I in range 8 to 15, yeah, so we should be getting our pawns. Self.white pawn bitboard. Oh, because I added the black pawns to the same squares, and then when they get bitwise, are they getting XORed? Anyway, alright, so we'll say this is going to be square 7, 14, 21, 28, 35, 42, 56, 63, 56. So here we need to, obviously, to at 55 and 48, I guess. Kernel restart and run all. Okay, why are these not getting added? Self.black pawn bitboard at I is equal to 1. Is that not how this works? For I in range 48, 55. Yeah, that should work, right? So black pawn bitboard at, so am I not stacking the pawns now? Yeah, I'm just missing the pawns from the V stack, so we'll do pawn and white pawn. We'll put this one after this one and this one at the very end. Alright, so let's try it. Kernel restart, clear output. Start and run all. Now I'm just missing one for each of those. Oh, I think maybe it's this actually. No. Okay, good. So now we have a bitboard representation of the board in its starting position, and we have a way to pre-print the bitboard mode. And I imagine that would also like to pre-print the non-stacked bitboard, like from a board square-centric representation a bit later. Maybe we'll pass that as an arg, but for right now, we'll rename this method preprint bitboard. And we'll just go ahead and run all. Okay, and that's the stacked bitboard for all of the pieces for both sides. All right, so now I'll create a Git repo. And I'll make it a public repo. And I'll push everything, including the notebooks, up here so you guys can check it out if you want. Let me just go to GitHub here. It'll be at wake engine, and so I'll just basically push all of this stuff. Well, rm initial git repo that we had here, and go ahead and push. I need to add the files, and actually what I'm going to do here as well is rm the git ignore, and I'm going to add a git ignore file from here, and I think that GitHub is smart enough to actually ask you what type of git ignore you want, which I like, and then we can type in Python here and get all of this by default, and I don't really care about adding it from the GUI here, so I'm going to avoid that. I'm just going to copy this, and then I'm going to pb paste this into git ignore from the terminal. Sorry, pb paste into git ignore. So there it is. And yeah, it has the Jupyter Notebook stuff in here as well, which I like. All right, so now we will git add git commit initial commit. Oops. Okay, so there it is. It's nice also that GitHub renders the Jupyter Notebooks for us. All right, so what do we need to do now? We have a bitboard representation for all of the pieces for the black and white sides in their starting positions. but the engine has absolutely nothing in terms of any types of rules about piece behavior. And this function to map from FEN to board state, this would be square centric, I think, or I guess technically it could also be to the individual bitmaps. What does FEN look like? If it's just like indexed by piece, like if a rook is always at a certain index, after 1 to c5. All right, so let's see, after 1e4. So this is presumably, if I had to guess, I'll look at the spec in a second. This is probably white's back rank / white's pawns / I'm not sure, 8 squares, 8 squares, 4 pawns, 3, I don't know what that means, 8 squares, and then blacks. Oh, so this is blacks and then whites, because this is the E file and it's saying that, wow, I have no idea. All right, so I'll have to understand what FEN actually, how FEN is actually representing the state. Contains 6 fields. Separator between fields is a space. Okay, so we have 1, 2, 3, 4, 5, 6. This reminds me of Advent of Code, which if you guys aren't playing this year, I would recommend. It's the first, not Advent calendar. I'm not logged in probably, but I started this year. I am logged in, but I've never done it before, and it's been pretty fun so far. So, all right. So piece placement from White's perspective, each rank is described starting with rank 8 and ending with rank 1. Within each rank, the contents of each square are described from A through H. Active color W means white moves next. B is black moves next. So that's this. So starting position, white moves next. That makes sense. Castling availability, if neither side can castle, this is dash. Otherwise, it has one or more letters. White king side. All right, so if anyone doesn't play chess, I can explain the king side and queen side and castling and that sort of thing in a minute. En passant, target square in algebraic notation. That's interesting that they devote an entire segment to this representation to en passant. So en passant is a special rule in chess, and we can look at that in a moment as well. If there's no en passant target square, this is hyphen. So that simplifies like the number of moves that a pawn can make, for instance. Half move clock, this is the number of half moves since the last capture or pawn advance. I see, so that makes sense. The 50 move rule is if any side, or if there have been 50 moves without a pawn move or the capture of a piece, then you can declare a draw. No capture, no pawn moves in the last 50 moves. And a move in this case is a player completing their turn followed by the opponent playing their turn. So if white moves and black moves, that's one turn. And then full move number is the number of the full move. It starts at 1 and is incremented after black's move. So there we see move 1 and then move 2. And then these half moves in between. But the half moves increment until piece capture or a pawn move. So that's nice. You can look at the PGN immediately and see things like state of castling. So I'll explain if there are non-chess players watching. If we open up an analysis board, need to play some tunes here. Okay. So I mentioned a few things. En passant, castling. All right, so let's talk about castling. All right, so castling king side in this case would be moving the king 2 squares to the right in this case, and then the rook comes around and is one square away from the king. And you do this so that your king can be protected, and in general you want to get your king out of the center of the board, especially after you've developed your pieces. So we'd be castling pretty early here, but it is a move. Castling queenside would work. Like, let's just make some other moves here. We'll just get everything out. Say black castles here. For some reason I play here, and maybe white starts something like this. I play here, and black plays here. Castling queenside works in this way, where I'd still move the king 2 squares, but in this case I move it 2 squares to the queen side. All right, glad to hear it, Sid Hunt. Yeah, the GitHub is up there, and I will continue working on our board representation momentarily. So this would be castling queenside. So you can see the king always moves 2 squares, whether it's kingside or queenside. Queenside means the left side of the board from white's perspective, the right side of the board from black's perspective, and it's called queenside because both queens start on the D file, and both kings start on the E file, and so kingside is to the right from white's perspective. What's the other one? Oh, there's some more rules with castling here. So like, for instance, you can't castle out of check. So like, let's say that we do something like this. None of this is really great, but all right, so now I'm in check. Let me do something else here. So we go here, let's say I do this and this and this, and then black does this. This is a silly version of this opening, but anyway, white can't castle here because he's in check, so he'd have to block or something before white could castle again. It's also the case that you can't castle if your opponent's piece intercepts the king's path, either queenside or kingside castling. So if I could just make some more nonsense moves here. All right, so let's make some completely nonsensical moves. All right. All right, complete nonsense. But all right, so black plays here, and now black is guarding the F1 square. White can't castle through this either, so that's another rule with castling. So you can't castle out of check, and you can't castle into check. You can't castle through a square that is guarded by a piece. And in this case, we can see that black's bishop is guarding the F1 square, and so we're not able to castle in this case. Another rule is that if the king moves at any point before castling, it's now lost its right to castle. So we saw an opening previously when I was playing with Alvaro earlier, when he traded queens early in the game, and he had to capture my queen with his king. So this left his king on a square on d8 in this case, where he wasn't able to then get it to safety by castling. And that happens in completely good openings as well. There are openings like there are lines in the Berlin defense, for instance, where the queens are traded, and the only way to capture back is with the king, and sometimes your king ends up in the center of the board in that way. But once you've done that, you can't go back and castle. So that's castling, kingside, queenside. En passant's the other thing that we talked about. So let's just play. I'm just going to play like complete nonsense moves here just to get to a position where we can do en passant. All right. It's like almost just hard to play complete nonsense, but let's do it. Oh gosh, it's all complete nonsense. All right, so we do this. All right, so now if black plays this is not a realistic game at all. But if black plays a move here where it doesn't, for whatever reason, black doesn't want to move his pawn ahead 1 square. He wants to move it ahead 2 squares to f5 in this case. White can actually capture here as if that pawn had just moved 1 square. That's called en passant. So when we were looking at the FEN notation, and it designated one of the segments to the en passant target square. That's what it's talking about when we talk about this en passant. And I could have just clicked on the Wikipedia article, but if you don't play chess, maybe it would be a little less easy to understand. But you can see here it's demonstrated again, just what we were just looking at. So this is white capturing en passant. Now, there's a caveat with en passant as well, where let's say white chooses not to capture en passant in this case. So he could capture en passant, but let's say that for whatever reason they choose not to, and then makes another move, and then black makes themselves to make another move. White can't now capture en passant on a follow-up move. So it's got to be when the move actually happens. Immediately after white has the opportunity, or the side that has the opportunity can play en passant. But if they choose not to for their turn, they can't play it on a subsequent turn. So those are some of the sort of tricks, I guess, that we'll have to bake into the chess engine. So because there are these sort of these rules that really depend on previous state and current state. So previous state in the case of like castling, if the king has moved at any point in its past, it's already lost its right to castle. And if en passant was not played in the first opportunity it was available, the same en passant move can't be played on a subsequent turn. So some things that depend on more than just the current state of the board. And so for things like en passant or castling, we can't just look at a board and say whether or not it's possible to do en passant or to castle in every case, because we don't know the previous history of the king, and we don't know, in the case of castling, and we don't know the previous history of the pawns in every case. Okay, because we could have reached this position as well, either here, or we could have reached it just again making any kind of move where we do this, whatever. You get the idea. This isn't the exact same position, but we don't know unless we know all previous states of the board, whether or not a particular follow-up move is the case. And so that's why FEN has those extra segments in it dedicated to en passant and castling. So now it makes some sense to me as to why they do dedicate segments of that representation to those states. All right. Siddhant, I will follow you back, my friend. All right. So, yeah, we were using numpy for this. All right, so what do we want to do next? Somehow soon we have to figure out how we're going to program the actual moves into our chess engine. I think I'm going to play one more game of chess before we do that. Feel free to challenge to a game if anyone likes to play. I'll play a 5-minute game. I like chess.com where you can kind of see where the opponents are as well. Hey Vic Cove, 6 a.m. at your city? Sorry, that's pretty early. Alright, so I'm going to castle here. Playing an Italian game again. This could get a little sharp. So yeah, so his idea is probably he's going to try to put I keep saying they're going to try to put the bishop on g5. I think this can get kind of sharp if I play aggressively by playing d4. E takes d4, c takes d4, knight takes no, then the bishop would have to go back. I'm going to play slowly, and they'll probably play bishop g4 next, at which point I'll try to kick it away with h3. They might also just play knight f6 is another common move. So knight f6 was played, and I'm just going to keep both bishop and knight away from g4 with h3. I think the position is pretty even. now he's playing a6 to support b5, presumably, so I'm going to try to stop that with a4. And now they'll probably castle. Another move is to play bishop e6, forcing me to trade off the bishops. So I'm going to try to tuck my bishop on c2. Okay, I'm not sure if I've seen this move before. So one of my thoughts here is to just play rook e1. If I play rook e1, they want to play bishop e6, at which point I'm always going to play bishop c2. My pieces aren't very well developed right now. I'm going to play rook e1. I realize that weakens f2 quite a bit, but I'm going to play it. And then at least one idea is maybe bishop e3. He'll probably play bishop e6 here. Yeah, he plays bishop e6, and I said that I was going to tuck away on bishop c2, so that's what I'm going to do. Now my idea is to play bishop e3 and try to get rid of his dark squared bishop, which is really strong. And he's got some pretty strong ideas here now himself. Do I win a pawn if I just play knight takes e5? Because his knight is hanging. Knight takes e5, and then what? Knight takes e5, queen takes h5. Unless I'm missing something. I could continue with my plan. He puts a knight on f4. I'm probably just totally missing this. But I'm trying to exploit the fact that, oh, does he have bishop takes f2 here as a sack? Bishop takes f2, king takes queen f6. Then I just bring the knight back to f3 though. My position's, I guess my position's still not great. So I think that he didn't have a plan here. So he was going to play, yeah, just knight takes. Now I have to take his knight. But I don't see what he's got in exchange for the pawn right now. For instance, if I just play d4, I'm forking queen and knight. And so I think that this is fine. Okay, so the problem with takes here is if I take his knight now, then he's got queen f2 check, and I don't have a good way to counter that check. So now I'm sort of regretting moving my rook to e1 now, and this is probably a bad move too. It looks like he at the very least might he might be just fine. This is just to protect against queen takes f2 when I try to take the knight. So he's got to move the knight now, but at least if he moves back to c6, I've got... Okay, well, I don't think this works because I have tempo. In other words, I attack his queen before he can attack my rook. And now I think maybe I have time to move to safety here. Is that true? So I'm up a knight, but I kind of need to clean up a little bit here. So I'm going to try to trade queens since I'm up material. I only have a minute left, so I also need to speed things up here a bit. He'll probably take the rook. Well, no, why would he take the rook? He'll probably move the queen. He should move the queen to safety. But yeah, so this doesn't work, right? Because now I have a discovered attack on his queen. Oh, I'm an idiot. Alright, so I guess I'm talking too much. Definitely talking too much. So now I'm just losing, actually. Material's even, but I'm about to lose a piece. Ay, ay, ay. So I was able to get away without losing a piece, but my position is really bad right now, so this is no good. No good at all. And my rook's actually trapped as well, so I am down a piece. And there's very little hope left in this position, and I have 11 seconds. So I blundered. Alright, good game. I resign. Alright, back to the programming. Alright, so let's see where I blundered. We can take a look at the analysis board as well, which is kind of fun. So now that the game's over, we can also look at the evaluation. And looks like I blew it in one move here. So I guess I played the opening okay. Not really. I blundered as well in the opening, but it looks like we both missed it. So my hunch with knight takes e5 doesn't actually work because he does have bishop takes, which is what I was afraid he would play, but I didn't see the follow-up. So let's see what the follow-up is. If I play here, I thought that if he played queen f6, I could protect with knight f3. But what's the tactic that he actually has? Let's turn it on. Oh, he's got a check. So he's got an intermediate move that I can't protect against. And so I'm completely losing my knight here. So while it looked like he had a pawn hanging, because I now have a revealed attack on his knight, it's not the case because he had two intermediate moves. One, he could take the pawn here, forcing me to recapture, and then he had a follow-up check here while my knight's still hanging. So the only move would be to move out of the way, and then he could win the piece back and actually be up a piece. So that was just bad calculation on my part. Luckily, he didn't spot it, and we got this position. I played okay here, and then actually the only move is to block with the queen, and so this actually protects everything and prevents my opponent from doing what he did after my blunder. So my blunder was playing king h2 here, and now he can just sweep up everything. So yep, and from here on out, it was completely lost. All right, GG. All right, so what do we need to do next? We have our bitboard set up. The generation of moves. All right, so where's move generation? Pseudo-legal move generation. Pieces obey their normal rules of movement, but they're not checked beforehand to see if they'll leave the king in check. It's left up to the move-making function to test the move, or it's even possible to let the king remain in check and only test for the capture of king on the next move. Quiescence search, sometimes supplemented by one for getting out of check. These special cases can be made more efficient than generating and testing each possible move to fit specific criteria. Chunk move generation. There was a blog for Crafty that I think I read at one point in the past. Yeah, by Bob Hyatt. Somewhere, I believe Bob Hyatt wrote information about actually programming a chess engine. I have a general rule that the quality of information on the internet is inversely proportional to the number of lines of CSS, so immediately I look at this site and I trust it as being really useful. All right, I'm going to bookmark this. We're going to keep with the chess programming wiki for right now. Crafty looks like it'll be a really good resource probably for learning, though, about building chess engines. I'm going to close some of the numpy stuff, keep our Jupyter notebook open. Worry about FENs when I have a more robust board representation with rules. All right, so now I need to figure out how I'm going to do move generation. Bitboard chess move generation. Generating legal moves efficiently. This person's writing a chess engine in Rust, which is cool. So one thing to say about building a chess engine is don't do it. It becomes an addiction and is never finished. Reasonably fast move generation function. This is a method that takes a chess position and returns a list of all the moves that can be made from that position for a given side. Simplest way is to do pseudo legal move generation, which does not consider checks or pins. That makes sense. So you can just check after you have a new state, but that seems not very efficient. Pseudo legal moves is a lot faster because you don't have to calculate extra stuff. It's actually more efficient, but you end up with illegal moves. Hey, Big B, don't know how to play chess, but hey. Yeah, that's all right. I'm building a chess engine or attempting to do a few live streams where we get one started because I enjoy playing chess, but I've never actually devoted serious time to thinking about how I would build an engine. All right, so this is all like square board representation rather than square-centric board representation rather than piece-centric. So we've built a piece-centric board representation with a bitboard. But if we're talking about like what squares, okay. Pretend the white knight's on a king square sees any moves from this square and land on actual white knights. My Rusker looks like something like this. Attackers, so mute in Rust is like a mutable, it's an actual variable, so it's mutable. So let attackers equal bitboard of 0, an empty bitboard. Attackers pipe equals knight moves, king square, and opponent knights. I presume this is still a bitwise and. By repeating this for every enemy piece, you can build a bitboard of pieces giving check. If it's not empty, you're in check. So if you don't play chess, the goal is to checkmate the opponent's king, and when you're in check, it means that a piece is attacking your king. So if we're black, our white knight here, which can move to the square e8 in this case, is attacking the black king on e8. And so if, theoretically, if it were the next move and we haven't moved our king, then white could capture the king. And so the idea is that when we're in check, in this case, we have to move our king out of check to prevent, or if we can't move, then that's checkmate. And so that's the goal of the game, is to checkmate the opponent's king. So in this case, the black king, even if black has other pieces on the board, unless black can either remove the piece giving check or move the king out of check, then black has no legal moves. In this board in particular, by the way, you can't checkmate with just the knight. The knight needs another piece, and you can prove that to yourself by playing around with the pieces and seeing if you could checkmate with the king and the knight. Obviously, you can't. So in this case, black has to have a place where it can move, and black can move to d7 in this case, or d7 or e7, f7, f8, or d8. So black has 5 legal moves in this position. Double check. So this can happen if the previous move in this case was, say the knight was here on e6, and then the knight moves to, in this case, g7, and the knight's delivering check, and the rook is now delivering what's called a discovered check, because a piece moved out of the way, which caused the white piece, which was hiding behind the knight previously, now to deliver check on the king. And whenever the king is in double check, there's nothing that you can do except move the king to get out of check. Because if you think about it, if two pieces are delivering check, there's no way for your opponent to capture two pieces at once. And so if black in this case captures the knight, the king is still in check by the rook. And likewise, if the black bishop captures the rook on e5 here, then the knight is still delivering check. So it's always the case that when there's double check, your king has to move. And if it can't move, then it's checkmate. So here, black still has a number of different moves it can make. Black can move the king to f7 here, or to f8. It could also move to d7 or d8, or yeah, d7 or d8 as well. Okay, but yeah, we need to be focused on the bitboard itself. I see there's a capture mask and a push mask. If we're in check, the capture mask is restricted to the piece giving check. I don't think we're ready to, I'm certainly not ready to think about how en passant works in the chess engine yet. Okay. So if I wanted to build a square-centric board representation, the moves are easy to think about in that context. So let's get rid of these for right now. Still have notes about the, this is fine. We'll just keep some of these notes up here. So let's do a square centric. In this case, we could have a one-dimensional array of 64 positions, or we could do a two-dimensional array with, eight length vectors as well, and represent it as a two-dimensional array or a matrix. And I think that maybe we'll do as a two-dimensional array. Let's look at what chess programming says about square-centric board representation. By the way, is there anything else right away we can do with this bitboard representation that we have? Let's look at these other bitboard basics before we move too far away from bitboards. Binary and unary operations, essential in testing and manipulating bitboards within a chess program. Relational operators on bitboards test for equality. Bitwise Boolean operators perform the intrinsic setwise operations. We've already seen a bitwise OR to get the position of all occupied squares. So I should probably call update bitboard state is update bitboard state is really update occupied squares bitboard. And this pretty print should be pretty print occupied squares bitboard. Init pieces. And self.bitboards is self.occupied squares bitboard. Also, I'm going to keep Lichess open in case anyone wants to play. It's been a pretty low-key programming evening, I would say. Or morning for those of you that are watching in the morning. Good morning. So it's not self.bitboards, but square in self.occupied squares bitboard. Somehow that's almost like less readable. Alright, so let's take a look here at general setwise operations. Relational operators test for equality as to whether or not they're the same or not. Greater or less in the arithmetical sense is usually not relevant with bitboards. Instead, we often compare bit for bit of two bitboards by certain bitwise Boolean operations to retrieve bitwise greater, less, or equal results. In C, C++, and Java, double equals is used. Yeah, okay, gotcha. All right, so if A equals B, both sets are equal. x86 mnemonics. All right, we're not worried about low-level stuff at the moment. Two important sets are the empty set, all zeros. Universal set contains all elements by setting all bits to binary 1. How do we get the numpy array to hex string? A.2 bytes. So if we were to look at our bitboard, oops, should make sure that this works now. This is update bitboard state, and it's pretty print occupied squares bitboard. Board has no pretty print occupied squares bitboard. What did I misspell? Board has no attribute update bitboard state. That should be update occupied squares bitboard. Board has no attribute occupied squares bitboard. Okay. All right, cool. So if we want to get the board dot white pawns bitboard, it looks like this. And if we save this to this and we do np dot, what's it called, hex, I'll keep the numpy docs open. Two bytes. Import numpy as np. Module numpy has no attribute hex. Sorry, just 2 bytes. I see. What happens if I stringify this? It comes out as a byte string. Okay. Bin ASCII? Okay, no worries. Alright, that's cool. Just curious. Alright, so let's come back and look at this. Bitwise Boolean. So I'm totally on board with these bitwise operations, but I'd like to, yeah, this is what I'm looking for here. So the intersection of two sets is a subset of both. Assume we have an attack set of a queen, and we'd like to know whether the queen attacks opponent pieces it may capture. We need to and the queen attack, so that makes sense with the notes that we had previously about intuition concerning bitwise anding to do piece captures. We need to and the queen attacks in the set of opponent pieces. So that's when we have, right, piece captures for different colors. To test whether two sets are disjoint, that is, their intersection is empty. Chess bitboards of the white and black pieces are obviously always disjoint. Same for sets of different piece types such as knights or pawns. Also, the set of the bishops for any given color will always be disjoint as well. So like all right. Well, yeah, for any piece really, because one square is occupied by one piece only. Okay, that's fine. Union. So we have the or. Disjunction is idempotent. Disjunction is commutative. Disjunction is associative. Disjunction is distributive over conjunction, and vice versa. So the union of two sets is the superset of both. Yeah, so we've already looked at doing the union on all of our piece bitboards, and we can see our occupied squares. So we actually have this. Since white and black pieces are always disjoint, one may use addition here as well. That fails for the union of attack sets, since squares may be attacked or defended by multiple pieces, of course. Yep. All right, so the complement set, how does this play in? Empty squares. Instead of empty squares, for instance, is the complement set of all occupied squares and vice versa. I see. Yep, that makes sense. The union of a set with its complement is the universal set -1. The intersection of a set with its complement is the empty set 0. Both are disjoint. Empty set and universal set are complement sets. That's just saying 0 and 1 exist as opposites. Well, it's not explicitly saying that, but it's basically, yeah, it's interesting. Empty set is 0, and universal set would be the universal 1. So I could create a bitboard to see all empty squares as well. And that's just the inverse of the self.occupied squares bitboard. We can make this a Python property as well. Actually, if I remember how this works, we could say get empty squares. Python complement. So the complement is tilde x. Numpy.invert looks like what we would do. Let's see if that works. Yeah, the not. I wonder if that's the same reason why in C# the destructor is tilde. Or finalizer is a tilde. It's a way of saying not the car, not, I don't know. That's silly. All right. I definitely need to get some more sleep actually. All right, but what we would do here is we would basically return self dot occupied squares bitboard, but here we do np dot inverse, was it? Also, I'm gonna have lag on the Dun, dun, dun. I don't need numpy data types. numpy.invert. And then I need to get a quick refresher on Python properties. Probably not necessary. All right, so then if we should probably also extract pretty print to be general use, and it should probably be in its own module. But what we can do is we could make this a static. How does this work? Static function. Oh, I'm too sleepy for that. All right, so self bitboard, and we're gonna rename this to pretty print bitboard again. And here we're going to print the bitboard that's past it. And this could actually just be a function, but we'll extract all of this kind of stuff later. We'll make it a static method. Static method should be a function or in another module altogether, but let's go ahead and this will now break, but we can say import board, and we'll call this board 1. Module board has no attribute pretty print occupied squares. That's right, it just has pretty print. Hello. Halo, it's hello. Thanks for joining. Pretty low-key stream right now, to be honest. I'm just kind of mumbling my way through thinking about bitboards rather slowly. Pretty print bitboard. Board 1 dot occupied squares bitboard. Pretty print bitboard. Oh, sorry. Yeah, so I don't need to do that. I can come back to this. All right, sweet. So now we should be able to pre-print any bitboard that we want, including the empty squares bitboard. I have a feeling that I'll have a bitboard module that gets imported into the board, the module that contains the board class itself, and the board class itself will also have square-centric representation. So, board occupied squares bitboard. All right, run all. And now we can, for instance, board pre-print bitboard for white pawns, which is cool. We should also be able to pretty print board dot say black rooks. This is cool. All right. So now we should also be able to do things like board dot pretty print bitboard for board dot get empty squares bitboard. All right, so that's not exactly true. np.invert occupied squares bitboard, it inverted. We should see empty squares. All right, what does this look like? Oh wow, -1 inverts to, or wait, what? What is numpy doing? Numpy complement array set diff 1d numpy flip 0 to 1. You just take 1 minus the array, really? That's a little bit of a surprise to me. But it works. Okay, so now we have a way to get empty squares. Okay. Okay, that's pretty cool. So we can pretty print pieces. We have a bitboard now for empty squares. What else can we do? We talked about the complement as being useful for finding empty squares. The bitwise union. We're already using that to find the occupied squares. This reminds me of Gödel, Escher, Bach when he's talking about the like at first it is surprising to me that the logical representation of the union and the complement are opposites, as opposed to the union and the union and the intersection. Like it feels like the union and the intersection represent sort of opposite states, in the sense that we have empty squares and occupied squares, but it's the union and the complement. Anyway. Okay, so what else do we have in this article? The XOR. Alright, so what are we going to use the logical entailment for? Material conditional, logical implication, or the Boolean material conditional A implies B. Bitwise less than or equals to relation. Alright, what do we use XOR for in our bitboard representation? Leaves all elements which are exclusively set in one of the two sets. XOR is really a multi-purpose operation with a lot of applications, not only in bitboards, of course. Yes. So this bitboard on the left looks like it could be the attack squares of two bishops on each of the long diagonals, the light and the dark square diagonal. This bitboard, what would this represent? I don't think there's a chess piece that this represents, but let's say the center squares in the board. These two XORed give you this shape. Okay, well, I'm not really sure what the implications are for this example that they're giving, but it's interesting. Okay, this is just more theory about XORs and set theory on different Boolean operations. More Robert Hyatt. This is the crafty guy, the guy who wrote Crafty. I have a feeling he's going to come up a lot on this chess wiki. All right, equivalence. Yeah, that's good. Shifting bitboards. Okay, in the 8x8 board-centric world, by board-centric they also mean square-centric, I think. With one scalar square coordinate 0 to 63, each of the max 8 neighboring squares can be determined by adding an offset for each direction. For border squares, one has to care about overflows and wraps from a file to H file or vice versa. This was solved in the square-centric case with the mailbox. What was it? Yeah, okay. Where they had the squares on the outside of the board. Such code is usually part of move generation for particular pieces. Little endian file, rank, and mapping. Okay, that's fine. In the setwise world of bitboards, where a square as a member of a set is determined by an appropriate 1-bit 2 square, the operation to apply such movements is shifting. Unfortunately, most architectures don't support a generalized shift by signed values, but only a shift left or right. So we can do bit shifting in Python, obviously. At least we have the bit shift operators. I'm really not sure what's happening at a lower level in terms of endianness or in terms of this generalized bit shifting. Alright, that makes bitboard code less general, as one has usually separate code for each direction, or at least positive and negative direction. Shift left is arithmetically a multiplication by a power of 2. Shift right is arithmetically a division by a power of 2. Since the square index is encoded as a power of 2 exponent inside a bitboard, power of 2 multiplication or division is adding or subtracting the square index. The reason the bitboard type definition is unsigned in C is to avoid the so-called arithmetical shift right in opposition to the logical shift right. Okay, I don't want to get that low level right now. More x86 mnemonics. The advantage with bitboards is that the shift applies to all set bits in parallel, e.g. with all pawns. Vertical shifts by plus or minus 8 don't need any under or overflow conditions since bits simply fall out and disappear. I see. Wraps from A file to H file or vice versa may be considered by only shifting subsets which may not wrap. Thus we can mask off the A or H file or after A plus or minus 179 shift. Post-shift masks, pre-shift masks. Main application of shifts is to get attack sets or move target sets of appropriate pieces, e.g. one step for pawns and king. Applying one step multiple times may be used to generate attack sets and move for pieces like knights and sliding pieces. For instance, all push targets of white pawns can be determined with one shift left plus intersection with empty squares. Okay, very interesting. For the sake of completeness, rotate is similar to shift but wraps bits around. Alright, I don't think we need to worry about rotation. Since single populated bitboards are always power of 2 values, shifting due to 0 left implements square to convert square indices to a member of the bitboard. Alright, we can play with this just for fun. What happens when we do a left shift on the starting position bitboard? So if I do, in Python we can just assign attributes here. So we can do like board.occupied board p is equal to board and actually this doesn't matter. Let's just call it p. Shift 1, and we print this. Okay, that's interesting. Left shift 1 doesn't do anything. Alright, let's take the empty squares board. Python bit numpy bit shift 1D array. Bits are shifted to the right x2 because the internal representation of numbers is a binary format equivalent to dividing. np.right shift. So x2. Okay, so what if we do is equal to np.right shift this by 2 by 1 by 0. So that's interesting. Did it cast the Python bit shift operation over the array? So this doesn't appear to actually do anything. Let's look at the black rook. What I need to like really internalize what's happening with when we bit shift these, and I don't quite understand it. So what if I just do this and then I print p? Okay, well, not quite sure yet, but it's good to know that we have these numpy functions available to us. Alright, I'm gonna play a quick game of chess. Oh, sleepy stream. Play the Elyekins defense. It's not very good for black, but I'm not a very good player, so it should fit well. And then I think e6, even though it looks kind of weird because we're giving up a central pawn, I think e6 is playable. So my plan is to fianchetto the bishop on g7. Yeah, so here, going to fianchetto. If my opponent plays, okay, so I'm gonna do this. Now I could chase away the, well, I'm just gonna castle first, maybe just try to develop my pieces. All right, so my opponent's gonna try to do a pawn storm here on the queen side by playing b4 in the next move. I'm thinking about playing a5 so that b4 can be met with a takes b4. Takes, rook takes, queen takes, and then my bishop is along this diagonal. If I play a5, I suspect my opponent will just castle anyway. So they do. I'm going to put my bishop now. Wow, bishop e6 would be a blunder because of d5. This light squared bishop doesn't really have a good square. And what's my opponent threatening? My opponent's kind of tied up at the moment. Okay. Actually, I'm kind of tied up at the moment, so I'm going to try to take the open file here. I suspect that what my opponent wants to play now is c5. If c5, that's probably a good move. I feel like feel like my bishop is not well placed on this square, but I'm not really sure where else to place it. So is there any way I can prevent c5? I don't know that I can prevent it, but I can start rerouting my knight before it's necessary. Okay, I'm not sure what this move is. So I'm going to move here. Okay. Just gonna kick the knight away. And then I'm going to push d5 myself. And now my opponent plays c5, which is probably a good move. I have a really cramped position. And yeah, I'm gonna try to trade off my opponent's light squared bishop, which is on a good diagonal. So I can do that. And now my idea is to try to get rid of my opponent's other bishop, which he'll probably just play something like bishop f4 here. Oh, and he doesn't, so he allows me to trade off the bishop, which I think should be good for me. And now the question is, can I sort of get my knight on c8, which is my worst piece, activated? He's probably going to look to double on the f file. I think I need to get my knight into the game. So he'll probably play like rook f3 or something if I were him. Rook f3, next move rook f1, maybe rook f2, rook f1. Rook c to d1. I'm not sure what the point of this move is. He really wants to break open the center now with e4. I think my opponent has a much better position than I do at this point. Yep, so he tries to break open the position. I really don't like what I've done with my position, but I'm gonna take, and now going to put, oh man, all right, I'm gonna try to simplify. This is probably a horrible move. I've got a serious weakness on e6 now. The hope is that he slips up and doesn't realize that, yeah, okay. I'm also going to lose on time, but I should have him. He has to take back with the knight now. Ooh, or the king, obviously. So I'm going to do this. Now threatening a fork. Okay, he misses it. That's good. So now I can pre-move some stuff, but it's not looking great in terms of time, actually. Oh, I had a good move there. So my opponent is way up on the clock, and even though I have a winning position, they'll probably flag me. So now the hope is to, well, I've got to stop this pawn now. If I can at least trade off all of his pawns so that he only has his knight, then at the very least I'll be able to, that'll be a forced draw. Gotta be careful not to blunder. If he tries a cheeky thing like knight e6, he doesn't. Alright. Trade, trade, trade. Not sure why my opponent played this way. Okay, so now I should be winning. Well, obviously, I've been winning, but I should win. Just in case. Alright, good game. That was too close. Alright, one more game. We have a Sicilian. Beth Harmon's favorite opening besides the Queen's Gambit. And this is not like a, this is not the way to play with white necessarily. So I'll do this. My opponent will play d6, protect the pawn. And my idea will just be to try to play some natural developing moves. But I don't have a great position. Maybe it's equal. So they call this the semi-open file because it would be open if there were no pawns on it. Okay. Here, I'm going to create a backwards pawn on b2. And let's see if I can chase this queen away. If he plays queen a4, I'll just move the knight back. And ask him if he wants to trade queens. He doesn't, and that's good. So I'm going to try to take the center now. I think that this isn't great because among other things, e4 is hanging. Yeah, but here e4 is hanging in the end anyway, but Yeah, not looking too good. Probably c4 here. Yep, c4. Okay. Well, for the moment, this is protected, but it doesn't look good. Okay, well, now my idea is going to be knight b5, knight d6. Almost want to pre-move it because I'm so slow right now. Also, the pawn on a6 is hanging at the moment, so maybe my opponent plays queen b8. Ooh, more aggressive move. I hope that this allows me to at least win a bishop. And then I thought the pawn is hanging, but then b2 is hanging. So let's try this. And now the pawn will be hanging. Maybe my opponent plays bishop h6 here. Oh, he just lets me take this and says that he'll just come in with the king. Now the queen's got to come, I suspect. Yeah, queen c5. I will play here to double my rooks. Then I'm going to try to put my queen on c3, unless he plays c3 himself. c3, yeah. Okay, I think I'm doing fine now. I probably have a moment to stop and think. I think I can force a trade of rooks. I could also just tease a little bit and my opponent goes back and we could play repeat moves here. He'll want to draw. Oh no, he won't want to draw. So yeah, I'm just gonna start simplifying. And actually I think this is winning now because yeah, now my opponent has to block with the queen and it should be over. I'll play f6, but the position is lost. I'll put the rook on the open file. I'll just play king e2. So just basically waiting for my opponent to make a mistake. But I'm up a queen basically. Well, not quite, but okay. No problems. It's funny whenever I start playing chess, it looks like more people join the stream. So maybe I should just be streaming chess. An average chess player streams chess. Chess has really taken off streaming wise on Twitch and on YouTube, thanks to Hikaru and the Botez sisters and many others. There are a few great channels from Indian chess players as well, but it's really taken off since COVID, I think. All right, I'm gonna play another one. If anyone wants to play, just challenge me on Lee Chess Westman, username Westman. All right, I'm gonna stick with the Karu Khan. As I mentioned, made fun of, or not made fun of, but mentioned as a bad opening in by one of the characters in Queen's Gambit. All pawns and no hope, I think he said. So this is the exchange variation of the Karu Khan, where after e4, c6, d4, d5, white plays e takes d4. I take back as far as I know. Knight takes c3, bishop to f5, knight f3, and now I play e6. All right, and then I presume I just have to block here. Oh yeah, Gotham chess. That's right. Yep. Oh man, I've fallen for this trap so many times. I think I'm lost here, by the way. XQC has tried. So I've fallen for this trap in the exchange Karokan before. I'm pretty sure that I'm lost here. Yeah, so I'm just lost, right? I won't get bored. You're more than welcome to challenge again. So I'm pretty sure I'm just lost here. I've fallen for this trap before. Um, there's no way to. There's no way to keep everything, right? This just loses a piece at the very least. Bummer. G takes f6. Just knight takes. Alright. Yeah, this is horrible. I gotta learn how to play the Karokan. Specifically, the exchange variation where I fall into this trap all the time when a knight lands on e5. So I'm down a queen. Try to trick my opponent. They're not gonna be tricked. Just queen takes f7. And they can sneak out. Try some swindling. Yeah, not gonna happen though. Not gonna happen. No swindle for me. Also, if anyone's wondering, I'm not using the chess engine that I am sort of working on to play chess here. Chess engine I have cannot even make any moves yet. Alright, so my bishop's actually on a good square. And now that the knight is moved, well, that's true. This doesn't really do anything at the time being. For the time being, I was going to try and threaten the queen here. Problem is that he's got knight takes b6 with check. Okay. I feel like this is a little bit of progress. I'm totally losing still, but point being now that oh yeah, this is mate. I'm getting mated. Mate into king b6, and then a4 is mate, right? Good game. Alvaro, if you're still around and you want to play, I'd be happy to play another game. Oh, a4 is not mate yet, but it's mate in like another couple of moves. Alright. The only trick I have, I mean, if I play king a5, then it really is mate next move. Rook b5. But there are many other mates in the position. Good game. Alright, one more game of chess, and then a little bit more coding, and then I'll wrap it up for the evening. I would like to try this. I think it was Gotham Chess I saw, or no? What's another Sicilian we have? What's the guy's name? Plays for the St. Louis Chess Club. Um, oh my gosh, I'm like falling asleep and just blundering these things. All right, blundering away. All right, I'm gonna play this one trap. This is a horrible opening. But there's a fun trap in here. I don't remember it exactly, but we're gonna try it. Pretty sure the next move that I can play. Let me think about this for a second. What's the trap again? Oh yeah, this is the trap. I'm glad I got to play this. So hopefully he plays takes. I should have pre-moved 97 because then it looks like it was a mouse slip. Um, the point is that if d takes e7 here, bishop takes f2, and then I win the queen. Pretty sure. Maybe I played that. Maybe I didn't get the trap exactly right. Yeah. All right. Yeah, I did not get the the trap right. But still, I think that this is still good. This isn't good. Oh man. Oh well. I forget what the exact trap is. Yeah, I'm not sure if I mean Ben Feingold. Um, there's another guy. So this trap did not work. Also, I think someone's challenging me. I don't know if that's you, Alvaro. Then I'll play you in just a moment. I totally botched this so-called trap that I tried. But we'll look at it in a second. Eric Rosen, I think, is the guy's name that I saw. Um, gosh, and I'm just playing complete garbage. Not like I'm capable of playing much better than complete garbage, but all right, I'm gonna take the challenge from Alvaro. Alvaro seeing me get crushed against the Sicilian by a few other players and now wants to crush me in it himself, so I'm going to play it slightly differently. I'm just playing very slowly, and this is not the way to play with white either. So, but good luck, sir. He'll probably play d5, attack the center. Okay. My pieces are all cramped. Alvaro's gonna castle. He's gonna play d5. Could play some horrible looking bind with c4 myself and live with this backwards pawn. What's my plan? I don't really have a plan. d5. d5 is coming. I'm sure of it. There it is. So I don't think I have anything in this position. Objectively speaking, after recapturing, the material is equal, and as far as I can tell, I have a worse position. Sid Snake's asking, do I release more courses on Udemy? I'm releasing a new course on Udemy before the end of December. It'll be my second course. And it's going to involve another full stack project, this one with authentication, and we'll look at building a CMS. I'll be doing another version on YouTube, which won't go quite into the same level of depth, but the Udemy course will also look at deployment and more in-depth feature development. Things like integrating with S3 to upload images, and yeah, user authentication using Entity Framework Identity. And yeah, should be a lot of fun. It's been a lot of fun to make so far. The code is finished, and starting tomorrow, I will be doing recording for that series. All right, so I think Alvaro's just crushing it right now. My position is really cramped, and furthermore, I think my knight is actually almost trapped. I think if Alvaro plays aggressively here, he's just gonna steamroll me. Like even f5 looks kind of nasty. I had to protect this pawn on d3 because of the double attack. My plan is to try to trade off one of my bad pieces for one of Alvaro's strong pieces. So he's got a really strong knight on f4 that for the time being is supported by the pawn on e5. So here, as I mentioned, f5 looked scary to me. The point is that my knight is running out of squares very quickly, and there's not much I can really do about it. And I feel like I'm going to get rolled over on this game. The one thing that I have going is that my pawn structure is slightly better, but my opponent has more space, much more active pieces. But here, alright, so I'm going to trade off my bad bishop. It's not a bad bishop in the sense that it's a different color from my center pawns, but it was not developed. And then yeah, so my knight's just like severely out of squares. Knight h5 loses to g6. Knight takes, takes, or sorry, g5, right? What do I do if g5? This is ugly. But I have to move, otherwise I lose the b2 pawn. Because if knight takes, queen takes, I have to move the knight, and then b2 is still hanging. Alright, I'm not sure what else I have. Not sure what else I have here. I think g5 is probably strong. Oh, this might be strong too. He's just protecting everything. And yeah, not sure how I'm going to meet all of my opponent's plans after g5 here. I could try to play a little bit more dynamically. So for instance, I'm pretty sure that queen g5 here wins. Interesting. So now I try. Oh man, I've got a bad position. I'm pretty sure like I should just be losing a piece here. And I'm about to lose it. I'm about to lose it. So at least, no, there is no at least. This is horrible for me. It's going to say that at least his king is weak, but his king is probably not even very weak at all. And I'm not really in time to do much about anything. Sidan says I'm looking sleepy and tired. That's because I am sleepy and tired. I probably should have stopped streaming at this point, but of course I haven't yet, and I will probably shortly. I'll probably pick this series up again though. We have some very rudimentary bitboards represented. Update notebook. I'll probably on my own here look at square centric representations and move generation next. So once I get a handle on move generation,